Hi, this is lesson 2.5 on trigonometry, and we're going to go ahead and start with these three problems here, which is essentially going to be just warm-up problems. Don't worry about this bottom portion here where it says measure each side and angle. Don't worry about that yet. We're just going to go ahead and start with these three problems. So go ahead and pause your video, work through the problems, get the answer, and then unpause to see how you did. Alright, here are the solutions. For the first one here, our first step would be flipping the -7 over to this side to make it a +7. Then we have an alliance. These are the same signs, combines to 15. And then the last step would be dividing both sides by 3 to get x equals 5. For this one, there are a couple of principles that we're using. Starting with this 65 degrees, the angle opposite, which is called the vertical angle, these are always congruent. So whenever you have two lines that intersect, the angles that are opposite of each other are always the same degree measure. So the same things, so going to this angle, these two angles together are formed along this line. So these should add up to 180 degrees. So if I do 180 minus the 65 degrees, I wind up with 115 as the answer. And so that's what we wind up here, 115. And then these angles here, this angle and these two angles together are vertical angles. So forget about this middle line for a second. This whole angle and this whole angle are both 115 degrees. That means these have to total up to 115. And so I subtracted 50 from the 115, so this had to be 65 degrees. And for the last one here, these are similar triangles. So that means the ratio of any of the sides should be proportional. So I should be able to take the 12 over 9 and set it equal to the x over 6, the corresponding sides, and then just solve the proportion. To get rid of the 6 in the denominator, I multiplied both sides by 6. It cancels here, leaving me with x. When you multiply a fraction to a whole number, the whole number gets multiplied into the numerator, so that's 72 divided by 9, which is 8. So this side is going to be 8. Yeah, and that concludes that portion. Okay, for the next part here, what I would like you to do is to measure the length of these sides in centimeters and go ahead and label them. Now, the one thing we're going to talk about is this angle right here, A, angle A. We're going to try and figure out what it is. Since these are referring to sine A, cosine A, and tangent A, this is going to be our reference angle. And if this is our reference angle, this becomes our opposite side. This, of course, is going to be opposite the right angle. And go ahead and put your right angle symbol here, showing that this is 90 degrees. So this is going to be your hypotenuse. And that leaves this remaining side as the adjacent side. So go ahead and measure these three. Pause your video, do the measurements, and then unpause. Okay, so hopefully you have those measurements written down. Now, if your measurements are just like 0.1 off from mine, it really is not going to make that big of a difference. For the hypotenuse, you should have gotten about 18.3. For the adjacent, this should be 17.5. And for this opposite side, you should have gotten about a 5.4. And so those should be pretty close to the lengths that you got. And now we're going to use this to actually find the measure here. So the next thing I'd like you to do is to get a protractor and actually measure this angle. And I'll go ahead and do it here with as part of the video. And I think the easiest way to do it would be to measure. I'm going to just flip this upside down. And nope, this is going to be the easiest way right here. Sorry, I made it more difficult. So I'm going to go ahead and line this up here. Line the line up there. Get the center of the angle in this circle here. That looks pretty good. And we can see it goes right through this angle measure, this line right here. So that's 10, that's 15, 16, 17 degrees. So we can see this angle is measuring 17 degrees. But what I want to show you is that the measurements that you took here can be used to find that measurement using these trig functions. Now remember, sine is your opposite over your hypotenuse. So sine A is going to equal 5.4 divided by 18.3. Now, in order to find A, I need to remove this sign. Just like in the beginning here, when I needed to get rid of this 3, so I get x by itself, I needed to do the opposite of what was happening here. This is 3 times x, so I divided by x because multiplication and division are opposite operations. These cancel each other, leaving me with x. Well, sine is its own operation. This is not sine times a, this is sine of a. Sine is the operation. If you look at a calculator, you can see that you have your sine button, and right above it, you have sine with this -1 up here like an exponent. This means inverse sine. This is the opposite operation of sine. So to get rid of sine, I would inverse sine both sides. So that's what I'm showing here, is that we're inversing this. This inverse sine and sine cancel each other, leaving me with just A. And so the next thing I would do is type this into my calculator. So we'll go ahead and do that now. Make this a little bit brighter here. Yeah, that's a little bit better. So I'm going to do the second button, and then sine, and you'll see the inverse sign show up. 5.4 divided by 18.3. And we measured, remember we measured here, said this was 17 degrees, pretty close to that. Well, we get 17.16 degrees. So we can actually get that measurement, I'm going to round it to 17.2. We can get this 17 degree measurement from the lengths of the sides without actually measuring the angle. And that's one of the things that trigonometry can do for us. There we go. And then we can actually do that with any of the trig functions. We can do the same thing with cosine. Remember, cosine is the adjacent divided by the hypotenuse. So we can say cosine A is equal to 17.5 divided by 18.3. And then we can inverse cosine on both sides. And remember, these cancel each other, so you get A equals whatever you get when you plug that into the calculator. So let's do inverse cosine of 17.5 divided by 18.3. And hit enter. And look, that's a 17.0. So I do want to point out we are getting some differences in our answers, and that's because our measurements are rounded. So one thing we need to remember is when I say 17.5 or 18.3 or 5.4, at some point I'm guessing, right? These are not perfect measurements, they are estimates. And so when you estimate, you are going to get a little bit difference in your answer, but about 17 degrees is pretty darn close. And let's go and do the same process with tangent. So tangent is going to be the opposite over the adjacent. So it'll be tangent of 5.4 divided by 17.5. We will inverse tangent both sides. That cancels. And then let's go ahead and do the math on the calculator. Inverse tangent of 5.4 divided by 17.5. And we get 17.1 degrees. So really we got pretty close values here. Probably something closer to 17.1 is going to be accurate for that. And that's very close to what we got, or looks pretty accurate according to what we measured there. And so that's the basic principle that we're supposed to learn from this lesson. This is it. This is the whole lesson. you can find the angle measures using the inverse trig functions as long as you know two of the sides. If you know two of the sides, you just need to figure out which trig function goes to those two sides. So let's take a look at these three problems, and what I'd like you to do is to work these three problems on your own. They are based on what you did on the previous side, and so go ahead and pause and you try those problems and then unpause to check. I do recommend doing one at a time. So work one problem, then check to see if it's correct, then pause again, work the next problem. This way, if there is an error, you're not repeating that error 3 times in a row, using the first check to confirm that you're doing it right. Alright, so go ahead and pause and start working on those problems, and then I will go over them. Okay, so hopefully you have the first problem done. For this one here, let's go ahead and start identifying which sides we have. The question marks here, this is the angle we want to find. Since this becomes our reference angle, this becomes our opposite side. And the side opposite the right angle is always the hypotenuse, which means this remaining side is the adjacent. Since we have the opposite in the hypotenuse, this would be sine, right? Because sine theta is the opposite over the hypotenuse, and those are the values we've been given. So sine theta is equal to 30 over 35. Now on the previous problem, I showed inverse sine to both sides. I did inverse sine here and inverse sine here. I'm okay if you skip and just go to inverse sine of 30 over 35. And then if you type that in your calculator, you will get 59.0. So that should be the answer you've gotten. Okay, so go ahead and pause, work the next problem. Alright, so hopefully this problem is completed. So I'll go and work through it now. So once again, this is our reference angle. Over here, this 6 is going to be the opposite side. Here's your right angle, so if I go opposite it, that's going to be your hypotenuse, which means this remaining side is going to be your adjacent. So we have the opposite and adjacent sides. That would lead us to the tangent function, since tangent is opposite over adjacent. So tangent theta is equal to the opposite side, which is 6, divided by the adjacent side, which is 4. So we'll do the inverse tangent of 6 over 4. When you type that in your calculator, you should have gotten 56.3 degrees. And now go ahead and pause, work the last problem, and then unpause. Okay, so hopefully you should have this last one done. Once again, here's our reference angle. If I go opposite to it, this is our opposite side, which we don't know. Here's our right angle, so this makes this side the hypotenuse, which the remaining side then would be the adjacent. Since we know the hypotenuse and the adjacent, that would lead us to cosine, which is adjacent over hypotenuse. Then we'll go ahead and plug in our values. The adjacent side is 8, the hypotenuse is 22. So theta will be equal to the inverse cosine of 8 over 22. Then we'll go ahead and plug that into our calculator, and it'll give us 68.7 degrees. I forgot the little degree symbol there in our other answer. Alright, so that concludes lesson 2.5, how to find the angle using trigonometry.